And I think I'm live. We're about 2 minutes early, so people should be rolling in soon. But if anyone is already here, say hello in the chat. And it's also always good to double check that you can hear and see my screen. So again, we're a little early. We'll take a few minutes before we get going. And I'll probably reiterate several things a few times just to get everyone set up. I see some people are already here. So I'll share these links again, like I mentioned probably a couple times. Hopefully you'll want to follow along today. We're going to go through some slides, but then this will be a lot of hands-on as well. And the only account that you probably don't already have is a Union account that you want to create. It's free, no card required or anything like that. You get $30 of cloud credit, which we're going to be using on a GPU today, which we're going to use much less than $30. It'll be, I think, less than $1, maybe even for the training. There's different ways we can do training. So if you change parameters, it might be more, but yeah, it's going to be very cheap for us to train our model today. But we're going to be using GPUs on Union. We'll talk more about what Union is later, but it's going to be the platform that we use to build our orchestration or our kind of whole pipeline in. So I'm going to share a couple links. One, sign up if you haven't already for Union. Like I mentioned, probably the only account you don't already have. The other thing is we're going to be using a Colab notebook to run through some of the code exercises as well. It's going to link to Union, so you'll need a Google account for that. I'm guessing most people here already have one. And to authenticate to Union serverless, you need a GitHub account as well. All right, and then also if you have any questions, put them in the chat, the live chat, wherever you're watching from, on YouTube or LinkedIn, and I will pay attention to the chat. If I miss your question, feel free to ask it again. I try to keep up to date with it, but sometimes there's a lot going on in there, and I might miss something as I'm kind of presenting through some stuff. And if you want to ask questions after any of the events, you can join the Slack channel. But during the event, definitely keep the questions in kind of the live chat on YouTube. So we're going to wait another minute or so for people to keep rolling in. I see quite a few people joined. So if you want to do some of the setup steps, I shared a GitHub repo in there as well. There's a button on there that says open in Colab. So if you want to run through the code before we get to it, you're more than welcome to. I know sometimes when I'm at an event, I like to do that as well. And let me just get a little setup here. So again, I see people joining in. Say hello in the chat. Maybe tell me where you're watching from. That's always kind of fun to hear. And if you want to add more context around, are you building something interesting? Are you, have you fine-tuned a large language model before? Have you run into any issues? So it's kind of fun to hear as well. While people are still rolling in, I can kind of preview what we're going to build here actually. So at the end result, so we're going to kind of do 2 or 3 things, hopefully, that you'll find interesting today. We're going to fine-tune a large language model. Then we're going to serve that in an app. This might be spun down, so I might have to refresh this here. And I'll talk about what that means if you're not familiar with deploying models. We'll deploy this model in an application where we're going to be able to add text in here, like some unstructured data. In this case, we're going to fine tune it for classifying movie reviews. And then we'll have this out in an app where you can actually interact with it, and we get a score returned. But to get to that point where we're fine tuning a model, we're also going to build a production grade workflow. So if you've never built a kind of a pipeline, maybe with some modern practices like caching, artifact management, that's what we're going to use Union for today. And we're going to build a pipeline that looks like this. We're going to download a data set, download a model. Sorry, there's a fly in front of me, so I'm going to wave it away. We're going to train our model. We're going to visualize our data set as well. Oops, wrong button. So we'll keep a log of basically, this is the data that we trained in. This is kind of what the distributions look like. We can evaluate our model. So we'll have a score of how well our model did on an evaluation data set, as well as how it performed on specific classes. And this whole workflow is version. So it's pretty common when you're training machine learning models that you're going to kind of redo this cycle quite a few times. as you get more production data, you might fine tune your model or change prompts or adjust some parameter. And then you still want to have usually everything logged in this version, so you can come back and troubleshoot and kind of see exactly what happened. In some industries, this is even more required, like healthcare industries. You can relaunch a workflow directly from a UI, pass in different parameters, or do this from the Python SDK. We'll mostly be working with the Python SDK and Python today. And I see some people have been joining in and talking in the chat. Awesome. So if you're just joining, say hello in the chat. And if you want to say where you're watching from, that's always really fun. Someone said hello from San Francisco. Awesome. Welcome, Richard. I love San Francisco. I go down there a fair amount. I'm going to be down there next month, actually. So if you have any recommendations, I always love hearing them as well. And someone said, excited to learn more about fine tuning. Hi from Newport Beach. Hello from San Diego. Hello from Denver, Colorado. Awesome. It's always fun to see where everyone is streaming from. And I'm in Seattle. So I'm streaming from Seattle, Washington. And we're a few minutes in. So let's go ahead and get started. Since I saw more people here, I'm going to share these links again. These should also be in the description. So if you come back and get the recording later and you want to follow along, these links are in the description. Again, the only account you probably have to create that you might not already have is that Union account. Again, it's free. There's no card required or anything like that. And you get $30 of cloud credit that we're going to use a tiny bit of today to train our model. And then there's the GitHub link again. So feel free to check that out. Again, I know, as other people are talking, sometimes I like to look through the code and poke around at it. So feel free to do that. But I am going to walk through all that code as well. So we're going to go through some slides to kind of introduce people to the concepts, make sure we're all on the same page, and then we'll do that hands-on portion with the GitHub repo or Colab notebook there. So if you want to get started, I'd recommend hitting that open in Colab. I like to save a new version as a separate file and then work from there. But again, I'll walk through that as we get to it. So welcome, everyone. We're going to be talking about fine-tuning a LM. Specifically, we're going to use a BERT model. I'll talk about that type of model here in a second. But also, everything we're going to see today can kind of transfer to different types of models. You might want to use a different chat-based instruction fine-tune model. You can switch that out, and I'll kind of talk about what you might want to switch if you're doing that when we go through the code. But again, we're going to build a pipeline, and we're going to deploy that large language model in kind of a Streamline application that we can then interact with. And then we'll talk about fine-tuning and implement that in Python and with Hugging Face. And we'll also see how to use LoRA and QLoRA. And I'll talk more about what that is in a second here. Just a tiny bit about me. My name is Sage Elliott. I work at Union. So again, that's going to be the platform we use today for kind of the workflow orchestration piece and serving. But also, if you end up not using that tool, I hope you're going to learn a lot of interesting concepts around kind of implementing a modern MLOps framework, when in your company, or how to think about it when you're deploying it. And then also we're going to talk about fine-tuning and Hugging Face. So if you took the code and kind of got rid of some of the Union parts, you could run that in your own Colab notebook, for example. I live in Seattle. That's where I'm streaming from, like I mentioned. I run an AI book an AI book club where we read a new book every month. If you follow me on LinkedIn, I post about it there. It's been really fun. It's definitely the most I've ever read technical books. It's been a really good forcing function for that. And then previously, I've done a lot of work in computer vision, ML monitoring, evaluation, MLOps, and then also on the hardware side, kind of gone back and forth between hardware and IoT and robotics. And then definitely now I've been more in the machine learning software side for several years. If you want to stay connected, here is my LinkedIn page. I try to post cool stuff in there. Like I mentioned, do a lot of community events as well. And someone said, thank you for doing this. They're a web developer, and they're located in Southern California. Awesome. Thank you for being here, Steve. Also, I see Rob said they're from Seattle as well. Awesome, awesome. And then, like I mentioned, if you want to stay connected, and there's actually an introduction channel too. So if you want to do a more permanent introduction later, join the Building AI Together Slack channel. And I'll talk more about what Flight is a little bit later too. But that's our open source orchestration framework that Union's built on, that thousands of companies use in production for their orchestration. So also a lot of what we're going to see today, you'll be able to implement in the open source as well. All right, so a little bit about you. We got people talking in the chat. It makes it way more fun for me. I think it also makes it way more fun for the audience. I see quite a few people here. So I know quite a few of you already said hello. That is awesome. But if you didn't already, put in the chat, where are you watching from? Maybe what are you working on? I think it's really fun to kind of hear about what people are working on, or what are you learning? Why are you interested in fine tuning or working with LLMs. I always love hearing kind of what projects people have. So if you haven't already, put that in the chat. It makes it definitely more fun for me. I think more fun for the other people watching too. All right, just kind of a note on fine tuning. And this is going to be kind of a quick crash course on a lot of these topics. And then we're going to go do the hands-on and implement everything. And so if we're going pretty fast or you feel like, you don't quite get everything, that's totally fine. We'll go through it in the code. I'll walk through it. And then some of the topics, if you haven't done fine tuning before, you could dive a little bit deeper in after the workshop or ask me questions later as well. But why do you need it? So usually with fine tuning, you take some sort of trained base model, and then you want to fine tune it or kind of retrain it a little bit on some of their outputs. So like you would have your own training data set, and then you want to not just have a generalized model, but you might want to have it learn specific things from your domain, and maybe have a specific tone or task that the foundation model you're using wasn't trained on. And this really helps the model excel in specific tasks like sentiment analysis, customer support, legal Q&A, medical summarization. Fine-tuning small models can outperform larger base models sometimes on those specific tasks as well. And so this becomes really important when you're putting stuff in production and scaling. You often get it faster, and you might have way cheaper inference. So a lot of people will say, why can't I just use GPT API to do this classification task? You probably can, but the costs kind of add up. So when you're doing this like after kind of the POC stage, it's not uncommon for you to take some sort of model, train in production, or train it for production. And then sometimes you also want to reinforce, really safe or compliant responses depending on which field you're in, and making sure you don't have like sensitive data that comes out for the application. So there's a lot of interesting use cases around fine tuning. You might even take a smaller foundation model, and maybe you're building an agent with it now, but it doesn't understand or isn't doing a very good job of calling your tools or functions for your agent. You might fine tune it to become better at that task. What is parameter efficient fine tuning? This is often abbreviated to PEFT, PEFT. So one, we're going to see kind of all these in action today, or how to implement all these different versions. So again, this is kind of just a crash course on it. FFT stands for full fine tune. So if you ever see FFT somewhere, that's usually what it means. This fine tunes all the way to your model. So you have, often millions, hundreds of millions, or billions of parameters for these large language models. And you load that in to your GPU or GPU memory. And then when you're training, you update kind of all the weights in your neural network. This can be really computationally expensive, but it often has kind of the best results for fine tuning. But to kind of get around that, there's a method called low rank adaptation, or LoRA, and it adds just a trainable kind of low rank matrices to your usually attention layers. We can add them to different places inside your neural network. And then instead of updating all these millions of parameters, you actually just update kind of this smaller section that you added into your neural network. And then you can actually get pretty good results from it. So you might have more than one of these. We'll talk about some of the places you implement them in. But it's something that you can experiment around with, like what matrices do you want in here? What size do they need to be to get good results? But basically, this allows you to do some form of fine tuning on much less compute. So if you have like a gaming computer and you want to fine tune a very large language model, chances are you actually might be able to use something like LoRA or QLoRA, which is LoRA, except for we combine quantizing the model. So we basically take a version of a model, condense it down. It's not going to have as much accuracy at this point because it's not at the full state that it was, but it's smaller. And then you can load that into memory and then fine tune a LoRA matrix here. And then again, you often get pretty good results with this. Today, we're going to look at the PEFT library from Hugging Face. I'm going to link to these as well. And then bits and bytes. Bits and bytes is the library to help with quantization. So again, this is kind of condensing our models down. And then the model we're going to use today, like I'd mentioned, where you're going to see we can actually change this out for other models pretty easily. And I'll call that out in the code. Basically, we're just declaring the model we want from Hugging Face. And then there's a couple other lines of code where you're saying we're using a model for sequence classification, but you can swap that out and then put in like a chatbot. So BERT is a bidirectional encoder representation from transformers. That's what it stands for. There's a lot of cool use cases around using this model for like text classification, semantic search, named entity recognition. And It's actually one of still, I think, the most downloaded models from Hugging Face. And I actually think it's very widely used, even though it might not like sound as cool or look at cool in some of the use cases versus like these foundation models. It's not uncommon when I talk to a company and I ask what model they have in production, especially if they're not like a startup, like they're a healthcare company or something that they're adopting AI. Often they have some form of BERT model, and there's different types. One just came out not too long ago called a modern BERT, which we aren't using today, but I recommend checking out. I actually even have a link to the blog post down here. So if you're doing stuff like classification on chats or something like that, and you want to know the sentiment score, this model is really good for it. So you can take unstructured data, train it to do something specific like we're going to see today, and get really, really good results on a pretty lightweight model. So the Dilbert model, which is the version we're going to use today, is only 110 million parameters. So we don't even really probably need a lot of the times the LoRA QLoRA for this specific model. But again, we'll learn how to implement it, and then you could bring in bigger models and it'll be more useful to you in the future. And then just a note on pipelines. So we'll talk a little bit about pipelines, and then we'll go into the code. So MLOps and LLM, now there's the term LLMOps as well, which really is MLOps, but some specific things around LLMs like prompt management, etc. But MLOps is really the set of practices and combining those practices with tools to kind of aim to deploy and monitor and maintain machine learning models in production. And then I kind of like to always think of the terms reliably and efficiently. And when I help people kind of implement their ML pipelines, these are usually the two things I kind of think a lot about, like how can I help optimize for cost, optimize for engineering time, optimize for collaboration between teams, depending on the team size, and then also a lot of times for compliance or kind of just lineage sometimes is really helpful with the team as well. But basically, this is a really simplified computer. I almost said computer vision. Again, that's what I've done a lot of work with, but really just ML lifecycle. You're going to be collecting data or having data from somewhere. Often you're going to have some sort of pre-processing step as well. Then we're going to train our model, evaluate that model to make sure that it is working pretty good on like a test data set. We might want to ship it out now. Then we ship that model. Once it's out there, you almost always want to have some form of monitoring, whether that's actually with a really cool platform tool like Arise, where you can monitor in real time, live chats or something like that if it's with a chatbot, or have something where you go in like every day or whatever time period is for you to go check and see how that model is performing. Because typically your model is going to drift at some point, or the data is going to drift coming in. That just kind of means that the data no longer looks exactly like the data was trained on. So it shifted slightly, and then chances are your model is not going to be performing as good because it may be out of that distribution of the training data for the model. And then you would want to hopefully collect that data in production if you can, kind of bring that back over, and then do this whole cycle again. So usually you're building this experimentation or production kind of a data flywheel or ML lifecycle, or a few terms for it. And you usually want to kind of repeat this process very fast and efficiently, and you're going to get a lot of benefits from it. Fortunately, there are many great tools to help with all those steps. You've probably used some of these before if you've done machine learning, like scikit-learn, PyTorch, transformers, etc. And we kind of tie all those tools together inside of workflows, which is kind of the core of building these reproducible ML pipelines. So again, I like the words reliable and efficient, and I like to keep those kind of two words and philosophy in mind, like when I'm implementing these. You also want to be scalable. So if you're spinning up a ton of data, like we work with a fair amount of self-driving car companies, their data sets are massive when they're spinning up their training workflows, and you want to be able to scale up compute when you need it, and then you usually want to scale it down so you're not paying for it when you don't need it. You want reproducibility, so you're going to ensure the workflows can run consistently. And if you've ever used Docker or Kubernetes before, both of these things might be somewhat familiar with you. And what we're going to see today is a tool built on top of Kubernetes, but it doesn't really feel like you're developing with Kubernetes. It's really easy. We're just add a few lines of Python, and you get kind of all these benefits that we're talking about. And in fact, we'll also define containers, the type of libraries we want installed, anything else in our environment, actually directly in Python as well, so we don't have to mess with Docker files. You usually want versioning. You're probably familiar with versioning your code and tracking that, but often with a machine learning model or some sort of workflow like this, you want to track not just the code, but also the data and the model and all the different artifacts between your whole in your pipeline between all those different tasks. You usually want to have improved efficiency. Again, this can kind of mean different things, but you want to allow your data scientists to focus on building like the cool stuff and not messing around with like a lot of the ops piece or thinking about how to handle data between different tasks. So often, again, when I get customers or people like onboarded with a modern workflow, they go from doing like experimentation from like weeks to days, or sometimes days to hours. It's kind of wild, all these different kind of things you can add in that might seem obvious or even small, and then they just add so much efficiency to the process. And then obviously cost efficiency is a big one too. You want to optimize resource usage. This also saves a ton of money. So just to hammer on a couple of the main points that I won't spend too long on this, but they really stand out to a lot of people. Again, some of these seem obvious, but when you add this into your process for your MLOps pipeline, it can make a huge difference. So one is optimizing for local and cloud development. This sounds really obvious to me, but not every team is set up for this or tool handles it well, where you can like write your whole pipeline locally, and maybe you don't have a big GPU, so you might use a smaller model, you might use a subset of your data set, but being able to test and debug locally before kicking off production cloud jobs saves a ton of time. Because if you've ever done this before, where you work with like a cloud environment and you kick off something and it has to spin up a container, then it has to run the code, and then you have to go hunt for the error inside that UI. It just adds, like, if it's minutes even per time you do a run, that adds quite a bit of time versus like debugging locally, which is usually a lot faster. Leveraging caching in the pipeline. Again, this might sound kind of obvious, where in this case, we're training a model and we're downloading a data set and pre-processing that data set, and we want to rerun this whole workflow several times to adjust hyperparameters or different values in our model. We don't want to download the data set and pre-process the data set every time if it hasn't changed and it's not useful to us for this process. So we can just cache that and then read that directly into our next task, which would be training the model in this case. Task level resource management and containerization. This one's really big for cost saving a lot of the time. So if we had a pipeline like this where we're getting the data set, pre-processing, and then training the model probably is the only place where we need a GPU. So we don't want to be spinning up a whole bunch of resources like a GPU and then spend potentially hours of downloading a massive data set to it. We only want to use a GPU when we need it in the training task in this case. So we can define specific containers and compute resources per task in our pipeline here. Mitigating errors of type safety. Again, if you've used other languages, you're probably familiar with typing, but basically it allows you to debug and catch errors way faster locally. There's several libraries that can help you implement this in Python as well. But basically, if you're defining a task and you're taking input as a string and your output should be an integer and you mess up the code somewhere, that it can yell at you kind of on runtime or compile time saying you messed up the code, and it saves a lot of time. So today we're going to be using, like I mentioned, Union. Specifically, we'll be using Union serverless. I had shared the sign up link for it for people to sign up for. Again, it's free, no card required, $30 of cloud credit that we'll use a tiny fraction of today. In order to use it, basically, we're just going to be adding these Python decorators on top of our Python functions that we're going to build for training. And with this, you get parameters like, do you want caching? What container image do you want to use? What are the specific resources? So kind of all the things we talked about previously are kind of baked in here, and we make it really easy to build that modern pipeline. And it's built on top of our open source, like I had mentioned, called Flyte. It's called Flyte, Flyte. Spelled that way because it came out of Lyft, I think, in 2016. I think it was started, or it came out. Yeah, I think it started in 2016. They open sourced it maybe in 2019. And it's run by the Linux Foundation. We're the core maintainers of it. Like I mentioned, thousands of companies actually use Flyte for production as well as Union. These are some of the Union customers too. So again, all over the place: biotech, fintech, autonomous systems, and more. And like I mentioned, a lot of what we're going to see today, like kind of that whole decorator thing here, this is a Flyte feature as well. So a lot of what we'll see, you can also use the open source for. So with that, enough slides. Is everyone ready to see and run code? I'm going to share the Colab notebook again. And I will share, the sign up link. For me, I think it's going to reroute. So again, take a minute to sign up. When you do sign up, it takes 3 to 5 minutes, I think, before you'll get like that kind of onboarding email as well. And if someone wants to let me know that the sign up worked, that's always great, again, for me to double check as well. And I'll go to the code in a minute, but just for the people who joined in, we're building this pipeline, and then we'll also see how to deploy our model. So I will open directly this GitHub link. And then I'm going to click this Open in Colab button. I will also share the link directly in the chat to Colab. And then what I recommend doing is go to File and hit Save a Copy and Drive. Then this will be your very own copy. So if you do want to edit the code or make any notes in here, you can do that. If you don't do that, it won't save any state that you have here. And then if you do mess it up, don't worry, you can always come back. You can star the GitHub or come back to this Colab, bookmark it. And then, so don't worry about breaking anything. You can come back and get this version always. So I'm going to do that as well. And now we are in my copy, and I will go ahead and scroll down. And what you want to do is run this first code cell. This will take a few minutes to run because if you've never used Google Colab before, it's a really cool tool. It's kind of Google's way of hosting a Jupyter notebook, which is a kind of an IDE where we can program in, but we also can have text and we can store output. So it's a really cool visual way of kind of programming and debugging. But Colab also comes with a whole bunch of libraries pre-installed. And so we're installing some libraries here. And one reason why it's going to take a while is it also has to uninstall previous versions. So it's not like installing all these libraries actually takes as long. The uninstalling, I think, is longer than the installation process. So this will take like 3 minutes or so to run. And while that's going, if you haven't already, you can run this before you sign up. So I would run this and then sign up for Union Serverless again. I'll share the link one more time. Should be in the chat already. And again, links are in the description too. So if you are coming back to the recording or it's easier for you, you can click on links in the description. And while this is running, again, I'll give everyone a few minutes to do the sign up, but I can also walk through maybe some of the code while this is going for about 3 minutes probably. Cool. And someone said that it worked for them. It took about 3 minutes. And I think I recognize your profile picture from were you at book club on Tuesday? I know that was on LinkedIn. I see your YouTube profile, so I don't know the I don't remember what, or I can't see your full name here. I said yes. Awesome. Yeah. Cool. Yeah. That we just read AI Agents in Action, which is kind of fun, and I'm excited to read the next book we're reading this month, or May 1st now, is building APIs for data science and machine learning, which we'll see a little bit of building an app today, which is kind of exciting too. All right, so this is still installing for me. Again, takes a few minutes because, like I mentioned, the uninstalling I think actually takes a little bit longer. While that's happening, let me kind of walk through again maybe what we're going to build, a little bit of the Union platform. Again, you'll sign in and this will look blank to you because you haven't actually run anything yet. You have projects, you can create new projects. Everything will run in default by default, and that's where we're going to run stuff today. You'll see kind of, if you go to this execution tab, these are all the kind of workflows I tried to run. Red means failed, purple is terminated, green means it ran correctly. And this is the train pipeline that I ran earlier this morning, which is what we're going to run today. And you get these different views. You get nodes, graph, timeline, so you can actually see how long each step took. I can click into these in any of the views, and I can click in and let's look at this train model. I can look at the inputs that were passed into this task, and I can see the outputs that came out of this task. In this case, we're passing a model out of it. You can embed visualizations, kind of like I showed at the beginning, where in this case, we are embedding a view of our data. I always do this. This has saved me again, actually, the other week on another personal project. Anytime I'm doing some sort of machine learning or deep learning, whether it's with text or images for computer vision, I always read in like my data set and show a sample to me. Maybe it's after pre-processing. If I did computer vision, it might be loading in the annotations, like drawing a bounding box around stuff, because you just never know if you accidentally read it in wrong. And I definitely did, again, on my computer vision project. So I always like to have a sample of what my data looks like somewhere in my pipeline that I can easily see. So here I just have this visual. I can click on this deck. Again, we'll see how to build this and implement this in Python. And this just has a little summary of the training data set. So we're using a training data set that's going to be on IMDb movie reviews. This chart is the distribution for negative and positive. It's a very clean data set from Hugging Face, so this isn't super useful here. It's always going to be even right now, but if I brought in my own data, I'd want to see the distribution of different classification that I have targets. And then I have a sample of this is what a positive review looks like, this is what a negative review looks like. And that's just for the training data set. And then we have our validation data set and then our testing data set. So I always like to have something logged here where I can come back in. And then if I was troubleshooting this model in production, we have this whole version saved. And even if we reran this workflow several different times as we're adjusting hyperparameters or something like that, or doing the LoRA and QLoRA, and we want to evaluate those against each other, we can always come back to this version and see that visualization there. And then same with the evaluation, we have this kind of embedded metric or score that we can go look at. So also this is useful if you're working with a team. Union serverless, the version we're using today, just as for a single seat, but the enterprise version that most customers actually use in production has like role-based access and can have multiple users. So this is useful for like a team kind of thing too. If people wanted to go see what workflow built a model, because you might have team separation, like a data engineering team, a training team, model shipping team. So again, makes it really easy to kind of share off artifacts, but also what produced that. We also have workspaces. We'll see apps a little bit later. This is the app that I showed where we deployed an app. We have workspaces. So actually, we could make a workspace and run a notebook in here instead of Colab, which I should try for a workshop. But Colab is pretty easy, and everyone has a Google account as well. All right, and then we have artifacts. We'll look at this later, but basically this is produced from the training workflow. This is the model. We can actually see that the model came out of here and where it was used. And then if we wanted to see, like this is version as well, and we want to see where this specific model came from, we can click on that workflow. And again, it will bring us back to that specific version and we could troubleshoot it. All right, so mine is done running. And don't worry about these errors at the bottom. This is because we didn't install a new version of Torch Audio or Torch Vision. We're not using it, so it should be fine. We can skip it. All right, so scroll down. If you have already signed up, you can run this code cell. If you happen to be a Union customer on an enterprise account, you can use your own URL here. I'm guessing most people are using serverless today. So you can do union create login serverless, authenticate device flow. So run this. This will generate a URL for you to click on. We can click here, and then it brings you this tab. Don't change anything there. Just hit next, and then wait for it to show that green check mark. And then you can go back to your notebook, and then it should authenticate this device essentially. So you could do this on your local computer as well, or any other device where you're going to kick off workflows from, or like consume artifacts from the platform. So once you've logged in like this, we can run a super simple workflow, and then we'll run the more complex one here in a minute. And I'll go through this pretty quick, but this is just to kind of introduce you to the platform and what it looks like. There's usually three main things that you want. Is one, a container image. So we're going to use image spec. It's built into Flight or Union, where you can define the specific packages you want, Python version, CUDA version, etc., directly in Python versus a Docker file. And then it'll kick off a build job in Union, in this case, build that container. And then when you use that container in a task in your workflow, it'll check to see if it's there. If it isn't, it'll build it. If it is, then it'll just pull it down. And it makes it really, really easy, so you don't have to go through all these different steps of doing container management or building. Then we have tasks, which are the kind of the building block of workflows. So in this case, we just have one task. But usually a workflow consists of multiple tasks. And you want to kind of, in the workflow, tie together how those tasks run in parallel or how data gets passed between them. So again, we'll see this in the more complex workflow. It'll make more sense. But basically, this whole thing is a workflow. And then each of these nodes is a task, which is like a Python function. And then you define the flow of data between all those tasks in the workflow decorator. So again, we'll see this in action here in a second, but let's build a super simple one. So we're defining our image spec. We're saying we just want flight kit and union in it. We're going to use the version of Python that is installed on our device here. And then we have just one task, and we're saying this is the container image we want to run on, which is what we defined above. And we only want one CPU, 1 GB of memory. And then this is our Python function. So again, we're just kind of adding this decorator on top of a Python function. And we also enforce strong typing. So we say we're going to take in a variable name. It's going to be a string. And then our function here is going to output a string. And it's just going to say hello name that we pass in. So this is kind of a hello world workflow that we're building. And then the workflow, we just have that single task. Again, workflows usually have more than one task, and we'll see way more tasks in our next section. So if we run this, and then we can run this union remote, which is going to connect us to the serverless remote thing that we authenticated in. And then we're going to run this execute command. We're passing in the workflow we defined, and then we're passing in this dictionary of inputs. And then if you click on this link, I don't think it has to build an image here, or no, sorry, it doesn't for me because I've run it before. So for you, it's going to build an image. It should be pretty quick because it's a very small image here with just those 2 libraries. But it'll say like image not found, building. Once it's built, you'll get this link. You can click on it, and it's already done running because it's a super simple workflow. But if I open up this tasks view, I can see my input was flight, what I passed in, and the output was hello flight. And then if I want to relaunch this whole workflow from the UI, I can very easily. I can pass in a different parameter here. So this makes it really easy too. If like you're doing something like hyperparameter optimization, you can have everything parameterized for your workflow and then adjust them and relaunch from either the UI, or again, you can also do this from the Python SDK as well. And then my workflow just ran, and you can see this has a hash for the version. And you can also see it's related to this original version. So again, everything's kind of tied together. You need to get all this reproducibility and visibility into everything that happens. And then if we ran this last code cell in this section, it's going to pull the output from the workflow that we ran above and then pull it down to the notebook. So you could actually, and in this case, we're writing all the code directly in our notebook cells. The next section, we're going to be running code that was downloaded from a GitHub repository. So you can actually kick off like production grade workflows directly from a notebook, which is kind of cool as well. Now, again, if anyone has any issues or you were able to do it, let me know in the chat too, because I can't see what's going on. So again, if someone wants to say, ooh, they were able to run it, that's awesome. Someone said, is Union AI replacing N8N? N8N, from my knowledge, correct me if I'm wrong, that's a visual workflow builder. And with Union, we're going to see basically you define all these workflows in Python. So I don't think so. We do have an option that's not in serverless as a visual workflow builder, but you have to define the tasks in Python and then you can drag them together. Most people, like from our use cases, like haven't used it. This is more of an engineering focused tool, and people want to write the workflows and tasks in Python and then execute them. So you do get this UI though. So once you have an engineer that could define the tasks, and then you have maybe a domain expert in biotech or healthcare, they don't want to write all that code, but they do want to pass in different parameters and stuff. I've seen use cases where people do stuff like that. So like someone will build this workflow, have parameters for someone to change here, and then run workflows from it. So I wouldn't say it's quite a replacement, but it depends on the use case. And someone said, sign up took about 10 minutes. Got it. Sorry about that. But it sounds like you signed up at least. All right. So we're going to go to the next section, which is the way more exciting section, in my opinion. Now, like I mentioned, when we ran that code cell that installed everything, it also cloned in a GitHub repo. And if I open this little file icon, we'll see that we have this BERT LLM classification pipeline. And if I open that up, we can see that there's folders in here, tasks, workflows, etc. So we're actually going to be running code that's already downloaded in these folders. And this is more structured how I would actually build a machine learning project, not just in a notebook for messing around or experimentation, but actually having this structured in a way that I think is cleaner and like how I like structuring my projects. So you can double click on one of these if you want. Again, you don't have to do this right now. It'll open up that code file and show you what's in there. You can also go back to that original GitHub link. It's all in the folders there. You could download them locally if you want to explore and click around that way. But what I did for the workshop that I'm trying as kind of an experiment is we're going to run these commands that will use those local files, but then I did also put the code embedded in a cell, but you don't have to run these because it's not actually like the code's already there. So this write file function is a function of Jupyter Notebook that will actually save a copy of this and overwrite what's downloaded. But right now, you don't have to run these code cells. You just have to run these command cells because the code is already there. So what I'm going to do is we should run this command, and then I'll talk through what it's doing, because it's going to take a while as well for it to, one, build a container image, but also fine-tune the actual model. So by the time I'm done walking through all the code, hopefully your workflow is actually done and you can walk through the UI and see all the output and then host the model as well. So run this. It kind of has a star here. Says run the BERT training pipeline. And then we are going to pass in these parameters. So we'll see how we define these in the workflow down below in a second. But basically we're saying union run. And then we have this remote tag. If we wanted to run this locally and not kick off a cloud job, we can actually just take that away. And since we're not on a GPU here, it would probably yell at us later. But this comes into where you can do the local development versus just cloud development all the time. And then it's in a workflow folder. And then we're saying, look at train pipeline.py. And then there's a function with the workflow decorator, which we'll see down below, that's called train pipeline. Then it has some default parameters for these, but we're passing in the amount of epochs, which is basically the amount of time our model is going to look at our data set. So we're going to choose 3 here. And then tuning method is going to be full. This is going to fully fine tune all the weights, but we will see you could pass in LoRA or QLoRA here as well. And it would train a LoRA adapter or train a LoRA adapter with a quantized model. And we'll walk through all that in the code. So if you do want to come back after the workshop or after this kicks off for the first time, you could actually run multiple training jobs in parallel if you want and overwrite this full with LoRA, have it all lowercase, LoRA or QLoRA, and then you could compare the models later. So for me, my container image was already built because I ran this before. For you, it'll say building image. Again, that'll take a few minutes, kind of like how we had to download all the libraries at the start. And then you will get this URL that takes you to the training job. And for me, because I ran this before as well, the dataset and download model are cached again, so we don't have to download those every time we run this workflow. And mine's already starting to train. It already has the visualized data that we looked at before. And then it'll do evaluate and then this predict batch sentiment task, which we'll look at later as well. So mine's kicked off. Again, yours will take a little bit longer, but I'm going to go ahead and walk through all the code that we just are executing from our command here. The one thing I forgot to embed here, which is fine, I'll just show it here real quick, is we have a containers.py, which is where we're creating our environment. So we saw image spec before in our simple workflow. This is what we're using for our fine-tune LoRA or QLoRA workflow here. So we're basically saying, get all the libraries from requirements.txt, which is all of these. And then we are giving a name, fine-tune QLoRA. Then we're also adding this parameter, which will look for a version of PyTorch that uses this version of CUDA, which is 11.8. Specifically, CUDA is the kind of a communication of like PyTorch to the GPU, and it's a specific version that we're installing into our environment here. We're going to build this container image on Union. And then we also needed some extra packages specifically for the quantization piece of the bits and bytes library. You need a C++ compiler. So we're actually adding those packages into our container environment as well. So that's where when we look at this code and it says like container, that's kind of the container image that it's importing and what your project is building right now. So let's look at this train workflow. So this, again, is the workflow tying together all the tasks and the flow of data between them. And then we'll go through all those tasks, which has like the fine-tuning piece and stuff explicitly in it. So here we have our workflow decorator, and then we have our function, which is train pipeline. And then let me just make sure. I thought I turned off my mic. And then we have parameters that we're going to pass in, which is going to be a string, which is going to be the type that of fine-tuning that we want to do. So by default, it's LoRA. We pass in full. You could also pass in QLoRA. This is the model name. So you could update this to be a different BERT model. And a lot of this would work out. I think when we look at the LoRA piece, you would have to change a parameter here when you swap out models, because you have to define which which layers you want to attach a LoRA matrix to, and that changes per model. There might be some way of automating it to actually like extracting linear layers and automatically applying it, but that's not in the code today. So if you do change out the model, just know there's like another line of code that you might have to change. And then the amount of epochs is 3. So again, it's going to look at our data set 3 times for today. You'll actually might want to update this to look at it way more times to get more accurate results. But just for the training time for this workshop, we're going to keep it at 3. And then we have this extra kind of test text, pretty common when I'm also building a pipeline. I also like having an extra node. Let me go find one that executed real quick that I can just pass in data to and see how my model behaves. So here we know we're training this for movie reviews, and I just passed in 2 sentences saying this movie's great, this movie's bad. Pretty obvious what those would probably belong to, but potentially if my model was awful, I would get results that I wasn't expecting. And I can see that I get the different labels returned, and it's actually pretty high confident. But I like to have a step where I can pass in data that I know isn't even in the training data set at all, or even close to it, and kind of see how it performs. So I like having an extra step, and that's what this extra test data is doing. And then this is the flow of data. So these are basically all the tasks. We import them from our task folder. We have data, inference, and model. And we are calling download dataset. Again, we'll see the code for these in a second. And then we have download model, basically getting the model, creating 3 different data sets here. If you haven't done deep learning before, it's pretty common where you have 3 different data sets. One for your model to learn from, which is training. And then as it's training, you want to get some results. And so validation data set, it can run like predictions on, give you some feedback of if the model's learning pretty good or not. But it's still going to be pretty similar distribution to the trained data set usually. And then you have a holdout test data set that you would run your model on after you've done like hyperparameter tuning or anything like that using the validation data set. Then we're going to download a model. It's going to save it to a directory. And then we're going to visualize the data like we already saw how we did that to kind of have tracking of what our data set looked like. Then we're going to call train model and pass in those parameters that we defined above. Then we have evaluate model. Like we saw, we'll get some metrics like accuracy, precision, and then also confusion matrix, so we can see which ones it got right and how it was leaning towards the accuracy maybe for specific classes. Then we have our predict batch sentiment. And then now this is going to be where all the actual tasks are. So that was kind of, again, us defining the flow of tasks and data between them. Here is our data.py file. So this has the download data and visualize data task in here. And I'll just more talk about these imports when we use them, I guess. One thing I'll note is when we're creating an artifact, if you remember, I went to the artifact tab. We'll look at it again later. But that creates a version of something that was produced from a task, and we can store it in a specific kind of tab where you can visualize everything and then easily pass these between teams or between other workflows. So to define that as an artifact in Union, you use this artifact method that we import and give it a name here. And then when you return it out of a function, you return it the type annotated, which is a Python type. And then you say the type of file it is, and then have the metadata attached to it as an artifact. So we'll look at our download dataset function. Again, this is our function here. This is the stuff on flight or union that we're adding to it to add those kind of efficient and reliable parameters for our workflow. So we have our container image. Caching is equal to true. Like we saw when I reran it on mine, it wasn't downloading the model anymore. Then we have cache version is equal to 1. So you could update this to a different cache version and create a different version of the cache. And then for this specific task, we don't want a GPU or anything. We just want 2 CPUs, 2 gigabytes of memory. It's not very computationally expensive. And then, again, we define our function, what it's going to output, in this case, 3 different data files. And then we are loading in the IMDb dataset from Hugging Face datasets. And then we are getting our train dataset and our test dataset based on a column in there. And then we're also making one extra dataset with train test split from scikit-learn. So we're going to get that validation dataset based on the training dataset. We're going to use 20% of it as validation. We're going to stratify in the label. Stratifying just means we're going to try to use an even amount of each label, so it's not like going to overfit on one of the classes. And then we're basically defining a working directory that's just in that container, and we want to save them all as CSVs. And then we want to return them out of the container. So by default, when you're working with containers, if you're new to it, it's kind of weird sometimes because you have this container that you spun up and it's doing something. And then when it's done doing something, it spins down and you go, oh, where'd the thing go that I was working on? Because you have to have some sort of way to pass it out of the container and be accessible. So in Union, we make it really easy, or in Flight, when you pass something out, it kind of saves it as saves it in your data storage. And then you can access it in another container as if it's kind of like stored locally. And we have two specific things called Flight File and Flight Directory as well. So Flight File is just a format that will be serialized and deserialized between the different tasks, and the same with directory. So you can just say, yeah, when I pass this out, it's now going to kind of live persistently in the data store, and then you can access it in different tasks. And so it exists outside of this container when it spins down. Then we have our visualize data function. I'll go through this pretty fast. There isn't anything super interesting in here. We're basically just reading those 3 data sets, extracting the first positive, negative review from them, and then plotting out the distribution like we saw was even for this. And then I guess one thing I should call it is in the task, we're enabling deck. That enables that button that we looked at, that we get. And then this can be any HTML or a markdown. So we basically get that data, and then we are embedding that into this kind of HTML report that we made. So it's really cool. You can build really flexible things here. You can even use interactive stuff like Plotly, for example. So if you actually wanted to have something with like drag and drop, or not drag and drop, like dragging sliders and stuff like that, you could actually embed this in there as well. So really cool. And then in that deck, we're appending the HTML report, and then we're just inserting it into the first tab here, but you can have multiple different tabs as well. So by default in here, you also get timeline, source code for that specific task, dependencies, and then the input and output as well. All right, so now this is the more exciting stuff. Oh, sorry, I've missed some questions. So, oh no, I think it's just one I missed. Is remote referring to remote GPU infra? So the remote, if you're talking about the first part in the remote for the code cell here, that was connecting to the basically Union remote here. This, since we logged in, basically connects your instance here, and then you can kind of do all the stuff we can do in the UI, you can do through the Python SDK once it's connected. So you could like grab all your execution runs, grab different outputs from them, kick off training jobs, but it's not specific to GPUs, only if we define that in a task and then rerun that task with a GPU in it. Right, so in our task model.py, this is where the training and evaluation happens. So again, we'll talk about these as we go. One thing is we're just returning one artifact from here, just the fine-tune model. You could have multiple artifacts. Probably a lot of the times I would have a base model return and then a fine-tune model, or we could return, instead of a full model, you could return just the LoRA adapters. There's a whole bunch of different ways of doing it. We're just returning one model today that we're going to use for deployment. Here we're defining our task again, pointing out the container image. Caching is true for this download model as well. And again, we just need CPU in gigabytes, a couple gigabytes of memory to download a model. Our output's going to be a flight directory. So the model for Hugging Face is saved in a directory with different files in it. And we're just calling auto model for sequence classification from pre-trained. So if you're using a different type of model, like a chatting model, like Gemma 3 or something, you would change this out to, I forget, chat completion or something like that, like the auto model for chat completion or whatever the parameter is here. And then you would pass in the model name. And again, we're just downloading it, not running it. So CPU is totally fine. And then we're getting the tokenizer as well. That's how this specific model chunks up text. And then we're saving both the model and tokenizer to this save model directory, and then returning that out so we can access it in our next task, which is training. So this one, again, pointing it to a container image. And then for this one, we actually want a little bit more memory and one GPU here. So this is actually the big thing, where most stuff should be running on the GPU. So we're defining a GPU. You can also define specific accelerator types in your cluster. So serverless that we're using today has L4s and A100s, and you can actually just, I should have an example here with that instead. By default, it's going to be an L4, but you can import a specific accelerator type and then set that here as well. Our inputs are going to be our 3 data sets, the amount of epochs, the type of tuning that we want to do. And then there's some other parameters here. LoRA R is, what is R? I think stands for rank. This is, I think it's rank. Basically, this is the how big you want your matrix to be. So remember, we're kind of adding this into a layer. And the bigger it is, the kind of better it can be sometimes. It can also overfit somewhat on data. But basically, you want to experiment around with this. The smaller it is, the lighter weight basically your matrix is. And then alpha is kind of the what's the word I'm looking for? Kind of like how much of an effect that this layer can have on prediction. So the higher number is a higher effect. And I think the rule of thumb people say is use this, how I set this as whatever you have for R or a little bit higher. And then you can also add in dropout, which will just kind of drop some of the layers and help for regularization and can help on not overfitting as much. And then we are just going to return that fine-tuned model, again, as an artifact, so we can access this in our next, not workflow, but actually deploy the model. We can also access it in other workflows. We'll show an example of that as well. All right, so then this is just downloading our model artifact that we passed in. And then our data set, basically, we're just downloading all those as well and then putting them into the Hugging Face format. Initializing our tokenizer from our model that we downloaded previously as well. We create a little function so we can pass in data and it'll be tokenized in the way that the model knows how to read it in. And then here's our first part for QLoRA. It says if the training method that we passed in was QLoRA, we want to import bits and bytes. So bits and bytes is a library that allows us to do quantization. And we pass in this configuration where you want to load into 4 bits. You can also, instead of 4 bits, use 8 bits. And basically, we're making our floating point smaller so our model can load in into less memory, but it's going to be less accurate the smaller we go. And then, we're skipping the classification layer because we actually want to have these at the full capacity, basically, as we're fine-tuning. And then we are, again, initializing the model for sequence classification from pre-train. And then we're passing in this bits and bytes configuration, though. Also, for a lot of models, you probably want to have this device type is auto. There's a library called accelerate from Hugging Face, where you can actually have it go from GPU and to CPU and kind of go back and forth. It doesn't work on DistilBERT because they don't have it implemented, so it's commented out here. Otherwise, if we're not doing QLoRA, we're just going to load in that model from our model directory without quantizing it. And then if the method is LoRA, we're going to initialize this LoRA config from the parameter efficient fine-tuning library. We're going to say the type is for sequence classification, pass in those parameters that we passed in before, like the rate, the alpha, etc. And then these are the target modules that we want to attach matrices to. So again, if you're using different models, you might have to pass in different parameters here. Otherwise, this might break. And you can look up. There's different ways of doing this, different layers that you might want to attach to. Typically, there's like 3 in a lot of the models. That's called like query key value, and they're all linear layers. And to attach the low rank adaptation matrix to this that we can then fine tune. But again, there's different ways of doing this. So you should look up kind of what's going to work for your use case and do a lot of experimentation. And then we're initializing the model with the parameter efficient fine tuning parameters that we pass in if we were doing LoRA. Otherwise, we just have that loaded model in, and now we get to call or pass in some training arguments, like the amount of epochs that we're going to train for, the batch size it's going to read in, evaluation strategy. There's actually another cool thing I didn't implement in this example yet. I'll probably go back and do it later, called early stopping, where if, let's say, instead of saying 3 epochs, we passed in 20, but after looking at our data set 10 times, the model actually started getting worse or not learning anything. Instead of running 10 more times and maybe making our model worse, you can add in something called early stopping, which you can add in the parameters of how it should early stop. So you could say, if you like ran for 3 more epochs and there was no improvement or it got worse, basically go back and take that best version of the model before that happened and then save it. So that's a really cool thing to add into your training pipeline a lot of the time as well. Then we're going to call a trainer. This now takes our model, our training strategy, and our train data set and evaluation data set, and then it's going to train it when we call it trainer.train. And then there's a couple of different ways that you could do this as well. Like I mentioned, you could save like the LoRA rank adapters as separate artifacts or anything like that. We're keeping it really simple for this workshop, where basically, if it's LoRA, QLoRA, we're going to take those layers and then just merge them into the model and save a version of the model with those matrices in there. But again, there's different ways of doing this. It depends on how you want to build your pipeline. And then we're going to save our model and then output it as an artifact. And again, we'll see how to access this artifact into other workflows or into like our deployment strategy. Then one more task here, we have evaluate. This is going to be pretty simple, so I'll go through super fast. We're basically importing our model that we just downloaded. So we actually have this train model directory that we pass in our workflow. We make sure it's downloaded into our container here. Again, initialize it with the same thing we've been doing. So not too much new here. Basically, we're then calling, one thing I should mention that I forgot to mention in the training workflow and in this evaluation workflow, I'm using a small sample of the data set. So the data set is like 25,000 or 50,000 samples, which would take a lot longer for us to train. So in the workshop, we actually just trained on 500. So if you scroll up, you'll see when we read in those data sets, we have the sample piece. It'll say 500 and then 100 for the evaluation data set. We're doing the same here for our test data set. We're just taking the first 100. So if you do want to make your model more accurate later, you can update this number or get rid of this sample piece and then just train on the full data set. But for the workshop, it would take way longer for us to train on those 50,000 samples versus just like 500. And then we're calling this pipeline from Hugging Face pipeline. We're saying the task is for text classification, passing the model and tokenizer. And then basically this is going to return predictions when we pass in text to it. So we're going to pass in our full test data frame and then basically get the scores and prediction for all those. And then we're going to calculate accuracy score, F1 score, precision, and recall. And then we're also going to create that confusion matrix. So if we went back to it, that basically creates this. So we have our score here. You can format this better in the HTML report. I just threw it in as a dictionary for now, but we can see our accuracy for this model, just looking at our data set 3 times on this kind of small sample size, is at 91%, which is pretty cool. And then the confusion matrix allows you to see for this class of 0, it accidentally predicted 5 of those as class 1. And for this class 1, it accidentally predicted 4 of those as class 0. So when you have more classes, the confusion matrix is really cool to kind of see which classes is your model doing well on and which one maybe needs a little bit more work. I have this commented out because I was going to implement the ROC curve, which is another way of looking at binary classification in a chart. It's not super important for this, but that's what that chunk of commented out code is. I forget why I didn't finish implementing that. And then basically we added the image for our confusion matrix to an HTML report, kind of like we did for the other ones. So your pipeline is probably done training as well. So you should be able to go to that URL. If you've already lost the URL, you can always go to union or serverless.union.ai, and then you should be able to look at your executions, and you should have this like train pipeline top in here. You should see this node view, and then you can look at this graph view if you want. And again, yours will have not read from cache here, so we'll have downloaded it. Should have a different symbol saying that it was cached. So if you rerun the workflow, which again, you could do from the UI, you could do it back in Python. You could do it from the UI and change this to LoRA and see how the model works. For our use case today, because we had a small sample of data set, like if you change this to LoRA, it's probably going to be way less accurate, and you want to up the sample size, and you might want to up the amount of epochs that it looked, the amount of times it looks at your data as well. So when we did full fine tuning just on 3 epochs, just from our small sample set, the evaluation is actually really good. So we went through a lot, and I definitely want to see if anyone has any questions for me here. While you're thinking of questions, and also let me know, like, did the training work? Did your workflow work? Did you build this whole pipeline? If so, definitely congratulate yourself. Like you built a production grade pipeline today. Maybe it feels like it, maybe it doesn't, depending on what you've done before. We kind of went through really fast. So, some stuff might feel a little foreign to you. That's totally okay. Someone said the workflow worked. Awesome. So I'm going to stick around for questions stuff, but I actually want to go ahead and go to this next part. Let's go ahead and serve our model. And again, we're going to do the same thing. You can go ahead and just run this command, and then I'll walk through all the code and tell you what's going on. So we have this union deploy apps, app.py, BERT sentiment analysis. And if I go into my union directory here and I go to apps, and we can see that it's actually deploying based on that new model. So this should go pretty fast. Let's see if it's actually already up. The first time you spin it up, it can take a little bit to load in the application. And again, we'll go through all the code of how this is working as well. Let's take a movie review. So this is from Rotten Tomatoes. It's kind of fun. You can go on Rotten Tomatoes, find some movie reviews. And also keep in mind, we had a pretty limited sample. We just used 500 samples. So our model might not be perfect, but let's take this 0.5 star review for the Minecraft movie, and let's see what our model thinks about it. Oops. Let me reload here. I think I have this in multiple tabs. We'll pass this in, and it thinks it's negative. That's right. And then let's take a pretty good one. Maybe, and we can look for ones that are a little more confusing, but this is a really long one, and mostly positive, 4 stars. So I'd imagine our model, again, it might not be perfect because pretty limited sample size here, should predict positive, and it did. Awesome. All right, so let's walk through the code, and then let me also see, I think there's a question in chat. Someone said, can we implement other examples from your past sessions offline? I think if you're asking for recordings, all of the recordings should be on the YouTube channel that you're watching now. If you go into the channel and then go to the live tab, most of them were live recordings. I think that's what you're asking. Or are you asking about running the applications offline? All right, so in here, we're basically looking at this app.py. And this is the code for app.py. I forgot to put it as a line at the top here. And inside app.py, we're importing some libraries from like Union, just like we did before. This should look familiar, except we're just throwing image spec directly into this file. Again, you could break this up into any way you want as Python files. So I often like to have like a containers.py, define my images in there, and then bring those in just for organization. But in this case, we have our image spec in one file for our app that we're going to create here. And we can see that we're calling transformers, union runtime, accelerate, streamlit, which is what we use to build our UI. And we'll see what this looks like. It's pretty easy to build kind of a nice UI for a web app in Python using it. And then we have bits and bytes. We're not actually using a quantized model today, but I set this up so that we could load in a quantized model if we wanted to later as well. And then we scroll down. This is our initialization of the Union app. We give it a name. We give it inputs. Our input is going to be that fine-tuned model that we just trained. And if I went back to the artifact tab in Union, we can see that this is my artifact. And basically, when I call it in the code as .query, it's going to bring in the latest one. But these are version 2, so you could pass in a hash and get a specific version if you want. But every time I launch this app, it's going to basically go see if there's a new version of that with this name. And then if so, it's going to pull it down. It's going to download it on the container spin-up. So it doesn't have to download it every time you query it or anything, just every time it spins up the container. And then we're initializing or defining what our container is, which comes from this image spec above. Again, we're not writing Docker files. It's all in Python, which I personally like a lot. And then this is kind of similar to our tasks. We're defining the limits and requests for the resources for our application here. So we're saying we want this many CPUs, this much memory. We want 1 GPU, and we actually specify the GPU down here. So we didn't do it before. By default, it is an L4, but you can import specific ones and say the accelerator in this case is going to be an L4. And we also say how much storage we want for the app. And then which port is it going to run on? This allows our app to know like where to look at to pull in the Streamlit app in this case. We can include more Python files. So we're also including main.py, which we'll look at down below. That's actually the Streamlit app. So we have two different files here. This is kind of declaring our app, and then the main.py is the Streamlit app that we're actually running. And then these are the arguments to get that Streamlit app running in this container. And then this is really cool. So if you've built, what was I going to say? Oh, if you built like or deployed applications before, you might know that you need to have like basically amounts of replicas to spin up and spin down. Basically, this is saying the min replica is 0, which means if no one has been using our app for, which is defined here, 5 minutes, it's going to spin down to 0, and we're not paying for any of those resources. But if someone visits the site for the first time and the app is spun down, it has to spin up, which again can take a while depending on the models you're loading in and stuff. So you could set this min replica to 1 if you want, and then max replicas to a certain amount. And you can have a scaling metric. So you could say when more than 2 users are on my app at the same time, spin up another replica. So you're basically defining all the scaling for the app directly in Python as well. And then this is commented out because by default, I don't want your app to go public unless you want it to. But you can uncomment this and pass in this parameter of requires auth equal false. And then you can actually take the URL and share it with people. Otherwise, they have to be logged into your Union account to access the app. So if we uncomment this and ran it, then you'd actually be able to take that URL and share it with like a friend or something like that. Again, if you uncomment it in here, what you actually have to do is go to the actual file that we're running, not in the code cell. But you could go to this app.py, make that change here, save it, and rerun the command above, and then you should have a shareable URL. And then this is the main.py. We're importing Streamlit. Basically, we're checking to make sure that the model loads in. If so, or if it doesn't, give us an error. And then we're adding a title. We see these when we go look at the app. The user input, you can adjust like what that cell looks like that you can type in. And then we have this button. And when we call that button, it loads in that model and passes the input into it, and then provides a different label returned, including the kind of confidence score from our model. And then we are just changing the color based on if it's negative or positive. And that's how we got this whole kind of running application that we can interact with now. Did anyone get this far? Did you actually get your whole app running? I know people said the workflow is running. Did you get this next part now with the application up and actually using your model, which again is awesome. You've gone through a whole thing of building a production grade pipeline and actually deploying a model in production with, we just have a max replica 1 by default here in our code, but kind of in a scalable production way again, which is really cool. And then there's a couple other things I can go through in the notebook if people want, but that's kind of I feel like the main core part. So I'm going to open up for questions. And if people want to stick around, I'll actually show some other examples of how we could use our model and Union or Flight to do batch serving, which is also really common. So instead of having a live app like this, you might want to, you might be okay with spinning up a container, doing a whole bunch of processing, and then spinning down that container. Maybe you don't need the real-time kind of feedback here. Or also you might want to rerun whole workflows, not just like an app like this with a prediction from a model. So we could take a look at that. It's the rest in the notebook. There's some really cool features in there. There's something called actors, which is a long running stateful container inside Union. Whereas before, when we ran our pipeline, basically you have to spin up a container for every single one of these tasks. With actors, you can spin up a container and then pass it between multiple tasks and give it a time to life, kind of like we did for app. So if a task hasn't used it for 5 minutes, it could spin down. So you're still not paying for those resources, but you can have those resources live longer across workflows or for batch prediction kind of examples. So it said, yeah, it works pretty good against the Rotten Tomato reviews. Awesome, yeah. And we weren't trained on those. Again, we were trained on IMDb reviews. And also, again, we just use a small sample. So you're going to be able to trick it, I'm sure, sometimes. Like we take, I'm trying to find like a 3-star review. Maybe this 2-star. This will be hard to know. Like if I just read this, I wouldn't know Well, I guess with not much substance outside of it kind of gives it away, at least to me. Let's see what our model thinks. It's a 2-star one, so it's negative. And yeah, picked up on it. Pretty good. 3 stars is interesting because is 3-star good or bad? It's not bad. Our model's only trained to predict good or bad. So let's see what it thinks. It's predicting it positive, which I guess 3-star is more positive, probably too. But again, our model isn't trained to predict stars. It's just trained to predict good or bad. But yeah, this one's hard because it's like they love Jack Black and Jason Momoa, but they were the highlight of this movie. I guess as in, nothing else good is in the movie. I haven't seen the movie. Any other questions or what do people think? Was this interesting? Do you feel like you learned something new? Any concepts that you thought were particularly cool? And also, I'll be building more examples around this. So if you have any specific examples you want to see, let me know as well. I'm working on some really cool computer vision ones. And then, like I want to kind of do this, but also with different types of LM. So if you want to fine tune a chatbot type LM, I'll be doing kind of a version of this with that type of model as well. And with that, it's interesting because you have to look at different evaluation metrics. Classification is kind of easy, got it right. There's a whole bunch of different kind of ways to monitor LMs that give unstructured output. It's way harder than getting a classification output and measuring it. Any other tools people want to see? Either like, have you used any interesting tools? I had in the slide, I forget if I mentioned it. There's a cool, really cool library that you should check out too if you want to do more with efficient training, called Unsloth. They also have a lot of quantized models on Hugging Face too. So if you're looking to use something like the new Quinn model and you want a smaller version, chances are they probably already have a version out with it. They're usually pretty fast. All right. Well, if there's still quite a few people here, if you're thinking of anything interesting to ask or feedback, definitely let me know in the chat. I'd love to hear like what you'd want to see next, or again, what you thought was most interesting. Let's go ahead. We can go ahead and look at kind of the last few code cells here, which might be interesting for some people. Someone said, this was cool, pretty fast paced. I haven't done this type of stuff before. No worries. And yeah, this is very fast paced. So it's very much kind of a crash course in all this stuff. And like you might want to go back and poke deeper into all the things that we mentioned if you haven't done any work on it before. But hopefully this kind of broke the barrier down of thinking like you maybe couldn't do something like this. That's kind of my goal with these workshops, usually show you something new, get you doing something as fast as possible. And like you could totally do it, even if some of the code or concepts you haven't learned about before and you want to go learn more about them. Like that's super common. And honestly, how I feel all the time as a programmer working in AI engineering anyway. So it's a feeling that you should get used to maybe a little bit too, which is like just saying it's totally fine if it feels out of your depth, but you're able to do it and you can, again, dive deeper in all these concepts later as well. And so it's that great session. Thank you. Yep. No problem. Always happy to do sessions. And again, let me know what you would want to see next actually as well. Like if there's any other libraries or models you're specifically using or that you found useful, would love to hear more about them. Someone said they will try the tutorial later. Yep. And you can always come back and get this recording at the same link that you're at now as well. So it just lives here. And all the resources or links to follow along, like the notebook and signing up, those are on the description as well. So if you do want to come back and rerun or share with anyone, you could do so. All right. So I'm going to quickly go through kind of another way of using our model. So I'm going to run this union register workflow batch inference. And I actually didn't put this in the code cell. So I'll just show it down here because I have it. I have this batch inference file. Basically, our workflow is very simple here. We're loading in a batch prediction or batch sentiment prediction task, which is what we used in our pipeline before. But now we're using it in a different workflow. So you can also switch tasks or reuse tasks into different workflows, which is useful. You can run workflows if you're on like Union Enterprise or Flight. in different clouds. So serverless, we're hosting the compute for you. You don't have to think about where it is. Most people with Union, you pay like a platform fee, or you set up the open source on your own cloud, and then you get access kind of to this abstraction to working with your cloud in Kubernetes. Here we have a workflow, and we have actually two. I'll just go through both real quick. This just loads in the batch sentiment task that we had used before. And then we have this other thing called actors. So basically, I'm going to show you two versions of running batch inference in a workflow, one without actors and one with regular containers. So again, actors are a long-running stateful container, and we can see some ways that that's useful here with this like kind of batch inference workflow. So if I go back here, we ran this register. Before we ran, when we ran a command, we hit run. It would actually run that whole workflow that we did. Registering it takes the workflow, that code, it puts it into Union, and then we can now run it from either the UI or from the Python SDK. You can also add different like launch plans to workflow. So if you wanted it to run every 24 hours and do something, you can do kind of all that sorts of stuff too, like scheduling. So we're going to use Union Remote again. So basically that code and workflows now are on Union. And we're going to create a little function here that I'll go ahead and run. And this is predict with a regular container. So we're going to pass in data, which in this case is text. And we're just going to pass in a list like we did before. It's going to fetch the workflow with this name that we defined when we created it. And then it's going to execute the workflow, passing in the data, and we have this wait equal true. That means this code cell isn't going to stop operating until it gets the value returned. And if I went to my executions, I can actually see there's one running right here, and it's just this task. It's loading in a model, and then it's going to take the text that we pass in and then give us a result back. And it's going to take, let's see, it's queued. It's going to take something probably like when it actually starts running, 20 seconds or something like that to probably load in the model and then give us a prediction back. I'm going to go ahead and just walk through the rest of the code real fast. With actors, and if we look at containers.py, which again, you can explore in that folder icon on Colab as well, but I'll just show it here since I already have it. We have our container that we made before for our fine tuning, but now we have this other environment called actor environment. And what we're doing is basically passing in this container that we had defined before, but we have other parameters we can add to it, like replica count. How many instances do we want to be able to create for this when we scale? And then we have this TTL, time to life in seconds. So here we're just saying stay alive for a few minutes. And basically this means when something's using it, it's going to stay alive. When something isn't using it for whatever we define here, like 3 minutes, it's going to spin down. But you could add this to be like pretty long, and this container is going to live for that amount of time. Again, though, when you spin up those resources, like if there's a GPU in it, like we have here, you're paying for that compute time. So you usually want to be pretty efficient with this, depending on, but it depends on like what you're doing and what type of task you're doing or expecting here. So this is going to live basically for 3 minutes and then spin down after that. So on, let's see if this is actually running. Like I mentioned here, each one of these spins up a container and a task every time by default. But with actors, if you're reusing the same container, you can spin it up and then pass it between these, so it doesn't have to spin up each time. And we're seeing this as an example in our notebook. Once this is done running, we'll do this other batch sentiment kind of prediction workflow, but we'll be using the actor environment instead. And so we'll run it 3 times in a row, and we'll see again, the first time it spins up that container will take just as long as the one above, like the 20 seconds or so or a minute to spin up. And then after that, instead of spinning up for these other ones, it's already up and it'll take like milliseconds to run, which is really cool. And I'll link to the docs later if anyone's interested in that feature. It's really cool. People love it. And it's really useful if you're working with massive data sets between different tasks, not just models. Like in this case, we're using a model. Oh, and the nice part about it is this is the task for the batch inference with actors. And you can call something called actor.cache. So when that container spins up the first time, you can do something like load in a data set or load in a model. And then that's just cached for the time of life. And then every time you do some sort of query to it, it's not doing this, but you have like a cache, large data set or model available for all of the other tasks to work with. So this is really common too, like when I talk with people doing like bio work with Flight or Union, where they want to load in like a really large data set for like some like a genome or something like that for some work around the area. They don't want to reload that data set in every task. So they just want to load it in once and then be able to use that data set in multiple tasks. Cool. We got the first one here, and we'll go look at our executions. Okay, and the other ones are running. So if we go look back at the execution tab, we can see these are all the ones I just called. And this first one, this is the regular container. It ended up taking about 3 minutes to spin up. And if we go look at our first actor run, oops, that wasn't our first one. That one says 13 seconds. Let me see. Maybe that container just spun up fast and the other one was pretty slow. You see, the first one took several seconds to spin up, like 20 seconds. And then we're able to rerun the same task without that spin up time. And that was just in milliseconds here, which is really cool. So again, also useful if you're not just running like a model real time, but you want to run whole workflows, not just inference from a model. Something like this is very useful, which is like a common use case too. Like we have customers that use us not just run a prediction, but to kick off a whole workflow basically every time involving a model. Like you might want to do a lot of data pre-processing, a lot of different steps there, and then some sort of prediction back. Cool. Again, so we went through a lot today. Depending on what you've done before, like some people said it was very fast paced. I don't know. I feel like I tend to like fast pace versus slow pace. Like if sometimes things are too slow, I get bored. So hopefully this is fun and then maybe engaging. I know there's still quite a few people here. So I'd love to see again, like, well, I'd love to hear if you liked it. Anything else you'd want to see next time? Was this interesting? Do you think you'd use any of the concepts that we learned today in a project or anything like that? Someone said, curious how much of the credits today's tutorial used up. Great question. If you look down here, it'll show what your balance was. So everyone should have started with $30 today. And if someone wants to throw their balance, what it is now, or if you can see it, let me know what it is in the chat. Because I think if you just ran the workflow once, training a model, it's usually not too much. Like I want to say it's like $1 or maybe even under before. Someone said 50 cents. Awesome. Yeah, thank you. Yeah, because I have a different amount of credits in here than what people start with, and I haven't been paying attention to it. A cool thing too is actually, it's a great point. Two things actually. So this isn't serverless. If you go to your train pipeline, I usually show this, but totally forgot to, is you can open up this train model section and hit this view utilization. And this shows you exactly the compute that it actually used. So we declared 12 gigabytes of memory, but it actually didn't need it. It only needed 1 gigabyte of memory. That's because everything was actually running on the GPU here. Same with the CPUs. So this is a good way of getting feedback too, of like, usually it's pretty common that you over declare the resources you need when you're building your pipeline. And then you can go see what you actually are using and then kind of bring that down, which will bring down your cost. And then inside of, let me see if I can pull this up real quick. Inside of the actual version of Union, like the enterprise version, there is a cost observability tab. Let me see if I can bring this up real quick. So you can actually get like projections of what's being used, and then you can hit cost, and this will bring up a whole kind of observability piece where you can see exactly like what workflows or teams are using what, which is pretty cool. It's not built into serverless. That's a feature kind of in the enterprise grade version. Also, again, serverless is just for like a single seat right now, not for multiple seats. So you should have pretty good visibility of what's going on. Someone said, very cool. Would definitely like to see the chatbot version. Yeah, I'll be working on that next. I have to find out what good model we can use. There's so many. I actually might look at the latest version, Quinn, and for the workshop, we'll probably use a small version so we can train on an L4. So again, it shouldn't cost us much money to burn through the credits. So I need to experiment around with that. And I know that they came out with like 8 billion parameter and 4 billion parameter versions of Qwen 3. And I need to mess with that and then find a cool data set to fine tune on that we can actually get results in the amount of time of a workshop. That's like the hard part. I feel like making something that people can do like in an hour and get results is like what I like. So it's cool. The classification one is cool because you get really, really good results almost immediately. And like I said, don't discount like BERT models. They're actually pretty widely used in a lot of different applications. I think they're kind of underhyped a little bit right now. Someone said, what happens behind the scenes behind caching? Is it something built by Union or available by Union or available by the cloud provider? To go deeper in that too, we can talk more in Slack with some of the people who actually work more behind the scenes on it. Like I use the product a lot and I build AI applications with it. I don't maintain kind of the core backend pieces. But the caching kind of works, I believe, where we write it to whatever your blob store is. So you define the storage on your projects. And this is actually important for like healthcare for sometimes, for instance, you have to think about where you're caching things. Like it can't always be in any cloud. So it's usually, again, on serverless, this is different. But with like Union Enterprise or Flight, you define your data plane and where everything gets stored. I'm not sure if that answers your question. If you have want to dive deeper, we can tackle that more in Slack with some other people. And also, it's open source, so you can look at Flight and how it's handled. Someone said, what was done specifically for ML training inference versus Union being a generalized task workflow framework? So that actually is kind of a general orchestration workflow framework. You don't have to use it for machine learning. You could really run any type of compute on it. There's built-in features that make it easy, like people want versioning, parameters, caching. We have other things that we didn't look at today, like parallelization with like map tasks, being able to capture the input and output and all the artifacts between things, are all stuff you use in machine learning. But you can actually use this for really any workflow orchestration that you want. Most of our customers use it for training workflows. Some are also just like complex data pipelines as well. But I would say, I think majority right now, it's like if you think of Flight or use Flight, you probably think of it for like building a AI training pipeline. But with that, we're definitely over time. Thank you everyone for being here, and still people hanging out, which is awesome. An hour and a half in. If you have any more questions, I'll actually share the Slack channel one more time too. So if you have any questions or want to dive deeper in to anything, join the Slack channel. There's also the intro channel that you can say hello in. And yeah, I'd love to see more people there talking as well. We also have the AI reading club that meets in there and online as well. So if you join, you can look for the AI reading club channel as well and see what books we're reading. But thank you, everyone. This is really fun. We had a really good turnout. I'm excited to hear about what you build next, or hopefully see you at other workshops. All right, I will talk to you all later. I'll end the stream.